Morning students. Today we are going to discuss here the topic hybridization. So that is a very important topic, hybridization. So I am going to discuss the topic hybridization. So please listen carefully. So first of all I will discuss what is hybridization. Hybridization. This is hybridization. If simply I will be discuss about the hybridization, so hybridization meaning when two or more than two equal energy orbitals, when two or more than two or more than two equal orbital mix या combine with each other. Orbitals combine with each other, then equal number of new orbitals are formed. Equal number of new orbitals are formed. Equal number of new orbitals are formed, which are known as hybrid orbital. Hybrid orbital, and this phenomenon is called hybridization. So if I will discuss about the hybridization, the meaning is simple in front of you. If I will be combine two or more than two equal energy orbitals, suppose this is the one orbital, this is the second orbital, both of these have the equal energy of the orbital. I am going to mix it. Suppose this is a thing in which I am going to add both the orbitals and I have to stitches it. मैंने इसको किसी मशीन में डाल के उसको सिल दिया. So what will be happen? They will be equal now. So on that time I am getting two orbitals, new orbital like one this and like one this. So these two orbitals which are formed by mixing that two orbitals, then whatever orbitals I am getting, that is a hybrid orbital, and this process is called hybridization as it is mentioned in the definition. Now how to find out the hybridization? One method I am going to telling you. Suppose anything is there and you want to find out the hybridization. So how to find out the hybridization? That also I will discuss with you. And what are the types of hybridization? That also I will discuss with you. So first of all, is how to find out the hybridization. So the way by which I will find out the hybridization. So one formula I am going to telling you: atom attached to the central atom. Atom attached to the central atom plus, keep in mind, atom attached to the central atom plus lone pair LP. Lone pair, that means the pair of electrons which are not going to bonded, that is free, that is a lone pair. So there some will be giving us some number. If by adding these two is coming, that meaning the hybridization is there, sp. If by addition 3 will come, then the hybridization is sp2. If by adding 4 will be coming, the hybridization is sp3. If 5 will come, this will be sp3d. If 6 is coming, this is sp3d2. As it is, if 7 will be coming, so this will be 7 will be coming, so sp3d3. So this is the way to find out the hybridization. Now firstly I will discuss with you about the sp hybridization, then I will discuss the example also, how it will be there. So that formula you keep in your mind, atom attached to the central atom plus lone pair of the central atom. That should be the central atom. So if their sum will be coming 2, then the hybridization is sp. Sum will be coming 3, the hybridization is sp2. If sum will be coming 4, hybridization is sp3. If sum will be coming 5, hybridization is sp3d. If sum will be coming 6, hybridization is sp3d2. If sum is 7, so sp3d3. Like that it will be coming about the hybridization. So let's see ki what is sp hybridization. I will discuss with you and I will discuss the examples also. The firstly I am going to discuss with you about the sp hybridization. Sp hybridization. This is sp hybridization. sp hybridization. Here you can see sp hybridization. What its meaning? Ki one orbital of s and one orbital of p, they are going to combine. Then they are giving us sp hybridization. sp hybridization. That is the meaning. So now the shape of the s orbital, that we know that this is a sphere. This is in the shape of the p orbital. This is a dumbbell. That is, whenever they will be combined, then they are giving us the two sp hybridized orbital, because one orbital is s, one orbital is p. So whenever they are going to combine and getting two orbitals, so the two orbitals in this way, this is like this. One orbital is this, and the second orbital you can indicate in this way. So that is. So this is the two orbitals. That is the hybridized orbital. That means I can say that this is two hybrid orbitals. Two hybrid orbitals. That is. Now let's see ki how it will be coming. If I will discuss here ki how much s character is there, what is the percentage of s character and what is the percentage of p character. So let's see ki how it will be. You can see ki one is s orbital and one is p orbital. So total orbital are here 2. If I will see the percentage of s, so how many s orbital is there? 1 upon total. How many total orbital is there? 2. Percentage means multiply 100. So this will become 50. So percentage of s is 50. Same as it is, we can find out the percentage of p. This is a 50. So percentage of p is also this is 100 minus 50. This will be also coming 50%. That means in the sp hybridization, s character is also 50 and p character is also 50%. Now let's see ki what will be the shape. If I discuss about the shape here, so as we know that ki in the hybridization, the orbitals, they are going to arrange in this way कि the repulsion is there minimum, उनके बीच में minimum repulsion हो. So suppose this is the central orbital. ये मेरे पास central orbital है. Okay, firstly I'm giving the example. Suppose I have the example of BeH2. I have the example. This is BeH2 beryllium hydride. So central atom is here Be. Central atom is Be. Whatever formula I have told you, if you will go according to that formula to find out the hybridization, so check out what I have told you. Atom attached to the central atom. The formula I have told you, atoms attached to the central atom, plus lone pair present in the central atom. Their sum will be indicate the hybridization. So this is the central atom. So how many number of atoms are attached to the central atom? This is 2H. So that is 2. This is the electronic configuration of beryllium is 1s2, 2s2. 2 electron is contained by the beryllium. Both are bonded with the hydrogen. That means there is no lone pair. So that will be 0. 2 plus 0, this is 2. I have told you if their sum will be coming 2, then the hybridization will be sp. So this is the hybridization of beryllium atom in BeH2. Now let's see ki what will be their shape. If you will be discuss about their shape, so what will be their shape? As we know that ki in a hybridization ki they are going to arrange in this way, the minimum repulsion will be there. Suppose this is the beryllium, ये मेरे पास beryllium है, this is. अब if you will see in the beryllium, so what will be the electronic configuration of beryllium? If you will see here, beryllium, if I will discuss about BeH2, beryllium electronic configuration is what? 1s2, 2s2, and in 2p also include, this will be the 2p0. यही होगा, because 4 atomic number is 4, 1s2, 2s2 and 2p0. This is the electronic configuration. If I will see the ground state, the electronic configuration beryllium in ground state, Be, ground state. So if you will see here, so I will go for the outermost shell electron. So this is the outermost shell. For S2s 1 orbital will be coming, and for 2p 3 orbital will be coming. This is, so 2 electrons are available here, 2 electrons are filled up here in 2s. This is of 2s and that is of 2p. There is a no electron, so I can fill up any one electron. Now in excited state, this is the excited state, what will be happen? One electron from the s orbital is going to excited whenever we are providing the energy, then it is going to fill up, one electron is here and one electron from here by getting the energy excite and enter in the p orbital. So here you can see, this is of the one s orbital and one p orbital, so that means this is sp hybridization. This is the other way to find out the hybridization. One of the s hybrid orbital and one is the p hybrid orbital. So one s and one p, that is they are giving us sp hybridization. Now the example, if you will check out, this is the beryllium shape. If you will see beryllium, here you can see one p orbital is going to participate here. So this is for the p orbital, this is, and one s orbital is going to participate. The shape of the s orbital is sphere. So this is the participation, this is for sphere, that is, and the angle that should be the minimum repulsion will be there. So that means the angle should be there. This is 180 degree and its shape is linear. It's linear shape, क्योंकि whenever they are going to arrange in the 180 degree, so linear shape will be coming, then the repulsion will be minimum. So that is why the shape of the sp hybrid orbital is linear and the angle is there 180. Hybridization is sp, example is BeH2. So that is the topic of sp hybridization. Now I will come on the topic, this is sp2 hybridization. What is sp2 hybridization? How to go with the sp2 hybridization? Let's see now. sp2 hybridization. This will be sp2 hybridization. The topic which I am including, this is sp2 hybridization. sp2 hybridization. Here you can see, in sp2 hybridization, one s orbital is participate and two p orbital are going to participate. One s orbital and two p orbital. Then the hybridization we are getting, this is sp2 hybridization. sp2 hybridization. This is, now the total orbital which are going to participate, one s and two p. So total orbital are here 3 orbitals. Total 3 orbitals are going to participate here. Now what is the s character in sp2 hybridization? The same s character, if you want to find out, so how to find out? Total number of s orbitals which are going to participate, only 1 upon total orbitals in the hybridization, that is 3. So upon 3 multiply 100. So 100 upon 3, that means 33.33%. So here s character is 33.33%. Now the talk about the p character. If I will go with the p character, so what will be the percentage of p character here? Here you can find out p character. This is the 2, because total orbital of p is 2 and the total orbital in the participation, this is 3, multiply 100. This is coming 200 upon 3, if I will solve it, 66.66% will come. So this is the S character 33.33% and P character is 66.66%. Now come to the point कि how they are going to arrange or how I can find out their hybridization. So check out their example. I am taking an example. This is B. One example I am taking here. The example is there, but I am taking BH3. BH3. This is the example. So firstly I am going to find out from the formula कि what will be same according to formula the number of atoms which are attached with the central atom. So how many atoms are attached with the central atom? 3. This is 3 plus the number of lone pair. This is the boron. In outermost shell it contains how many electrons? If you will see, this is 1s2, 2s2, 2p1. So total outermost shell electron that is 3. All the 3 electrons are bonded with the hydrogen. So that means there is a no lone pair. This is 3 plus 0. It is coming 3. As the 3 sum will be coming, then the hybridization is there sp2. So this is the way to find out the hybridization with the formula. Now the other way that I will discuss with you of the hybridization, that also I am going to discuss ki how it will be there. Please check out now. Boron electronic configuration 1s2, 2s2, this is 2p1, that is 2p1. This is now if you will see here the ground state. If I will talk about the ground state, so what will be there in the ground state? So I will take the outermost shell. This is 2s and this is 2p. In the second orbital, D is not coming. That is I am not going to mention D. So in 2s 2 electron is present, 2p 1 electron is present. This is now I am giving the energy to this ground state electronic configuration. That means in excited state, one electron is going to excite and enter in the p orbital. So that means one electron is here and one is already present and this electron is entered here. Now you can see here 3 equal hybrid orbital is going to form, which contains same electrons, and this is the 1s and 2p. So that will be coming sp2 hybridization. sp2 hybridization. This is now the shape. If you will be see here sp2 hybridization, so this will be the triangular planar. So how I will be arrange that you can see. It will be too easy. Let's see how I am going to arrange. This is I am having this boron. This is boron sp2. If you will see here, this is sp2. In sp2, how it is going to arrange, that you can check out. This is 1 p orbital, then this is second p orbital, this is third p orbital. That is they are going to hybridize. किससे hybridize हो रहे हैं, किसके साथ combine हो रहे हैं? S orbital से. So this will be coming here S orbital, this will be coming here S orbital, this will be coming here S orbital. Now you can show they are coming in this way. This is and this is. So this is a trigonal shape for the sp2 hybridization. So I hope about sp and sp2 hybridization is clear. I am coming on the topic. This is sp3 hybridization. sp3 hybridization. sp3 hybridization. This is sp3 hybridization. How to find out? Now you can see here in sp3, 1 s orbital and 3 p orbital are going to participate here. 1 s orbital and 3 p orbitals are going to participate here. So you can see the total number of orbitals here 4. Total number of orbitals are here 4. If you will see about the s character. So what is the s character available here? How many s orbitals participate? 1. This is 1 upon total orbitals are here 4 multiply 100. So this is coming 25. So 25% is the S character available here. Then what is the P character available here? Rest of is the P character. Rest of is the P character. Either you can go 100 minus 25. This is coming 75%. Otherwise, you can find out from the formula. Total P orbital is 3. Total main orbital is 4. Multiply 100. This is coming 25. 3 is 75%. This is also the way to find out the S character and P character. Now, from the formula, if you want to find out about the sp3 hybridization, so you can take the formula is here. So any formula, example you can take it here. You can take CH4. You can take example here CH4 for sp3 hybridization. You can see the example of CH4. Suppose I am having CH4. This is. If I want to find out from the formula, so how to find out from the formula? Let's see. The electronic configuration of carbon is 1s2, 2s2, 2p2. This is, so that means carbon contains 4 electrons in the outermost shell. All the 4 electrons are bonded with the 4 hydrogen. That means around the central atom 4 atoms are attached. So this is 4. So all the 4 electrons, the carbon is bonded with the hydrogen. So there is no lone pair is present. So lone pair is 0. 4 plus 0 4. If the sum is coming 4, then the hybridization is there sp3. Hybridization is there sp3. So the hybridization of CH4 is sp3. That I have to find out with the help of formula. If you want to go with the help of the other way, so check out in the other way. The electronic configuration I have mentioned here. So in the ground state, if you will see, so outermost shell, this is 2s and this is 2p. 2 electrons and this is 2 electrons. This is of 2s and this is of 2p. After that, when one electron is going to excited, so excited state, what will be the structure? One electron is going to be excited. So from here, electron is going to remove and enter in the p orbital. Enter p orbital, and when it is excited, enter to the p orbital. So you can see we are getting the 4 hybrid orbitals of equal energy. 1, 2, 3, 4. In these 4 hybrid orbitals, one is of s and these 3 of p. So hybridization is there sp3. So this is also the other way to find out the hybridization. So both the way I have explained you. One with the help of formula and one with the help of electronic configuration. This is. Now I will talk about the shape. So the shape of the sp3 hybridization, if I will talk about, so the shape will be there. This is tetrahedral. This is tetrahedral. Now how I will be arranged in the tetrahedral form? Please check out कि टेट्राहेड्रल शेप को मैं कैसे अरेंज करूंगा. अब इस टेट्राहेड्रल शेप में कैसे कैसे ऑर्बिटल पार्टिसिपेट कर रहे हैं. मुझे पता था 1 ऑर्बिटल इज s एंड 3p ऑर्बिटल. दिस इज, तो s ऑर्बिटल की शेप तो मेरे पास ये हो गई इसमें. अब p ऑर्बिटल होता है आई हैव px, py एंड pz. सो लेट दिस इज द px, दिस इज px, देन दिस विल बी द py, this is py, then pz. So this is the pz. So they are going to participate here. They are going to participate. Same I am going to arrange it there in tetrahedral form. How do you can check out? Let this is the carbon. I have carbon central atom. So this is one pz. This is of pz. Then you can arrange it in this way. This is of pz. Then after that, this is the orbital. क्योंकि 4 ऑर्बिटल थे मेरे पास जिनके बीच में ओवरलैपिंग हुई थी. सो ये हो गया p और s में होगा. सो दिस इज 1p, 1 2p. दिस इज 3rd p and this is 4p. 4p and this is the 1s orbital, 2nd, 3rd, 4, क्योंकि s और p orbital are going to participate, so that is why that is going to indicate it. Now if you want to show, so this is the tetrahedral. Now the angle between them, this is 108 degree, 108 degree and 109 degree 28 minutes. 109 degree 28 minutes. The angle is there 109 degree 28 minutes. That is. So this is about the sp3 hybridization. After sp3 hybridization, I am moving for the sp3d. sp3d. How it will be there sp3d. Please let's check about the sp3d hybridization. sp3d. So here you can check out in sp3 hybridization, one s orbital, 3 p orbital and 1 d orbital are going to participate. So total orbital is there 1, 2, 3, 4 or 5 orbitals. Total orbitals are here 5. Same you can find out the s character, you can find out the p character, you can find out the d character. So the formula already I have told you. Same for s character, 1 orbital of s, total is 5 multiply 100. This is coming 20%. Same for p and same for d orbital. You can find out yourself now. I hope you have understood. Now these 5 orbitals, how they will be arranged themselves. So they will be arranged trigonal bipyramidal. They will be arranged trigonal bipyramidal. Again trigonal bipyramidal shape होती क्या? That we want to discuss. So suppose trigonal वर्ड यूज किया मैंने trigonal. So मेरे पास 1, 2 and this is 3. This is a triangle. This is a triangle. And pyramidal के लिए हमारे पास that is ये होगा हमारे पास pyramidal. That is a pyramidal. Now please check out. ये दो these two ऊपर नीचे जो है ये these are axial bone. Keep in mind axial bone. And these are those are in triangle form. These are equatorial bone. ये कौन सा होगा हमारे पास equatorial bone. Equatorial bone. Keep in mind. ऊपर नीचे axial bone and the triangle form. This is a equatorial bone. The axial bond is always greater than the equatorial bond. Keep in mind. ये जो axial bond है, this is always greater than the equatorial bond. You can see there. Axial bond is greater than the equatorial bond. Now the example I will discuss with you of trigonal bipyramidal or sp3d hybridization. So the example is there PCl5. Example that I want to discuss with you. This is PCl5. Same the formula if you want to follow, there is no problem. How many atoms are bonded with the central atom? P is the central atom. 5 Cl is going to bonded to 5. So any lone pair is present on the phosphorus. It contains 5 electron only. All the 5 are bonded with the Cl. So that means there is no lone pair. So this is coming 5. So already I have told you if the 5 sum will be coming. So hybridization is there sp3d. sp3d. This is the hybridization. This is the formula 1. Now again coming on the topic by the electronic configuration. So the electronic configuration of phosphorus I am going to write it. This is 1s2, 2s2, this is 2p6, 3s2, 3p3, 2, 4, 10, 12, 15. Phosphorus is 15, this is a 15 and 3dG. Because in third shell the orbital is going to originate or participate. So this is 3dG. Same, the outermost orbital we are going to represent. Here outermost orbital is that third. Outermost orbital is that third. So in third orbital if you will be see, so ground state. Ground state. If I will be seeing the ground state, so this is for 3s, then this is for 3p, and 5 orbital for 3d. 1, 2, 3, 4, 5. This is for s orbital, for s 1 orbital, for p 3 orbital, for d 5 orbital. Now this is 3s2, 2 electron is entered, 3p3, 1, 2, 3, and there is a no electron. This is the ground state. Now in excited state, what will we have? Excited state. So what will be happen in the excited state? The one s orbital electron is going to excited by gain the energy and enter to the d orbital. So that means I am getting this is 1 because that already contain 1 and 1. Whatever electron is coming here, this is going to excited and enter to the d orbital. This is. Now you can see the total hybrid orbital we are getting here of same energy, that is of 5, in which 1 s orbital, 3 p orbital and 1 d orbital. So hybridization is there sp3d. This is the next way to find out the hybridization. So I hope it is clear. The shape already I have told you about the sp3d hybridization. This is trigonal pi pyramidal. Now after that, next I am going to discuss this is sp3d2. sp3d2 sp3d2 sp3d2. Now this is sp3d2 hybridization sp3d2. same, you can check out 1 orbital of s, 3 orbital of p, 2 orbital of d. So total number of orbital is 2 or 3, 5 or 6 orbital. 6 orbital. Same criteria to find out the s character, p character and d character. So the formula you know. I hope you can use it now. One more example I can use. Suppose now I want to find the d character. Suppose. So what is the d character available here? If you will see 2 orbital of d, total is 6, multiply 100. So 2 3 is 6. So this will be coming 33.33%. The way is in front of you. As we are going to find out the percentage, I am going to keeping it. Now after that d orbital is going to participate. In d orbital you know कि d orbitals की naming हमारे पास क्या है. So the naming is there. Keep in your mind dxy, dxy, dyz, dxy, dyz, dzx, dzx. These three, keep in your mind dxy, dyz, dzx. These are axes. ये axis, ये कहाँ पे प्रेजेंट होंगे? एक्सिस पर होंगे. एंड रेस्ट ऑफ डी एक्स स्क्वायर माइनस वाई स्क्वायर एंड डी जेड स्क्वायर. दैट आर द नेमिंग ऑफ द डी ऑर्बिटल्स. कीप इन योर माइंड dxy, dyz, dzx, dx square minus y square, dz square. That are the naming. Now the shape is there octahedral. इसकी जो शेप होगी, what will be the shape? If I discuss about the shape of the d orbital, so what will be the shape of the d orbital? That is a octahedral. अब octahedral हम बनाएंगे कैसे? This is a confusion. बहुत easy है. How to find out the octahedral? कि octahedral shape बनेगी. Too easy. There is no problem. Make one square. एक स्क्वायर बनाया हमने. This is a square. ये सेंट्रल एटम हो गया. This is 1 2 3 4. That is after that total 6 orbital is going to participate. इसको आप ज्वाइन कर दो. ये हमारे पास octahedral shape हो गई. You can join it. This is the octahedral shape. That is too simple. There is no problem. Now the example is there SF6. So the example हमारे पास this is SF6. Same I am coming on the formula. The number of orbital which the number of atom which are attached with the central atom. Central atom is sulfur. How many atom are attached? That is 6. Sulfur contains 6 electrons in their outermost shell. All the 6 electrons are bonded with the fluorine. So lone pair is 0. So 6 plus 0. This is coming 6. And the total is coming 6. So the hybridization is there sp3d2. sp3d2. Now the formula, if I will go to the electronic configuration, so let's check how I will go to the electronic configuration. So same sulfur, the electronic configuration is 1s2, 2s2, 2p6, 3s2, 3p4 and 3d0. So these are the last orbital electrons. So in ground state if I will represent, so what will be the ground state? Please check. is ground state. This is 3s, then 3p, 3s and 3p. After that 5 orbital for 3d, 5 orbital for 3d. This is 1 2 3 4 5. So that are the 2 electrons in 3s, 4 electron 1 2 3, and this is a 4 electron. 3d is having 0. This is the ground state. Now in excited state, what will be happen in the excited state? Total orbital was there 6. How many we have? 1 2 3 4. So 2 orbital are more needed to make the hybrid orbital. So 1 electron from here and 1 electron from here, they are excited and enter in the d orbital. So we are getting, this is 1, this is 3, and this is 1 2 3 4 5 6. 1 orbital transfer here, 1 electron transfer here, 1 from here, 1 from here, that is 2. So 1 s orbital, 3p orbital, and 2d orbital. So the hybridization is there, sp3d2. In SF6, the hybridization of sulfur is sp3d2. This is a criteria to find out the hybridization. I hope you have understand about the hybridization topic. Now in my next video, I will come with you the next topic to find out the hybridization of cations and anions. The formula is a little bit changing. I will do it. That I will discuss with you in my next topic. Thank you. Have a nice day. Goodbye.